All right, I think we can start the class now. I think we have nearly 120, and we're already 5 minutes past 2. Okay, all right. So for those who have already in the class, so today we're going to use a Mentimeter. Can you just go to Mentimeter and then you put in the codes? Okay. So try to understand the situation right now. So I'm giving you two questions today. So the first one will be on the eye drops, okay, which is the one that is presented now. And we're going to have another one, which is parenteral injections, okay. So given here, you have RZ, salicylate 0.5% eye drops, okay. And then some other informations given, the instructions, the durations, as well as some of the properties of the drugs here. So the PKB is 6.5. The freezing point depression value of it is 0.122. Okay, and then additional information for this particular drugs. It is easily degraded in the presence of air. Okay. So have you got the informations? Okay, so you may want to mark down, or you can just print screen or whatever, so that I can keep the informations. Okay. So I think all good to go. So let's look at the first questions. Okay. So based on the information just now. Okay. So again, for those who just came in, can you just quickly jot down the informations? So the first things I'm going to ask you is about the formulations of with what is essential for this particular formulations of prescriptions you're receiving. Okay. All right, I think we have more people joining. Okay, can you just quickly print screen the informations? Yeah, I think I put the information in the chat box in case. Okay. Okay, so in case you missed the information, I have just put in the chat box. So for those who just came in, don't forget to log into eLearn for your attendance. Okay, based on the situation just now, so we have RZ salicylate 0.5% weight per volume, eye drops. Okay, some instructions and some of the information about the drug itself. The PKB is 6.5. The freezing point depression value is 0.122, and it is easily degraded in the presence of air. So what are the strategies do you think you want to put if you have these situations happen to you? Okay. So let's see. So if you wish to talk in between, or you have any questions, I think you feel free to voice up. Okay. So I hope to have some discussion with you all so that you all know what is going on, and more interactions that is not only one way, and also through some of the tools using here. So probably I need you to give some solution later on. There will be some later calculations as well as some labeling. So what I'm trying to discuss today has a little bit how to say correlation with what you're going to prepare for your practical class later on. It will be started with the tutorials. So all this information or these discussions today will be very helpful for you. Okay. Okay, so far when we look at the spider web here, so we have more. Do we have more people? Okay. So by looking at the situation right now, I think we start from the very top. We have vehicles, preservative, buffer, antioxidants, viscosity adjusting agents, tonicity adjusting agents. So start from the top. Vehicles is a must. Okay, I think majority of you chose to have vehicles. Okay, followed by, I think the sequence is followed by the what we have here. Okay, I can see that then your choice is preservative. Only 90% of you choose to have a preservative. Then buffer, antioxidants, viscosity agents, and tonicity agents. Okay. So then look back at what we discussed that day. Okay. So this is an eye drops. Okay. So we have also indicated here that this eye drop is going to be used for 2 months. Okay. Unless it is a unit dose or a single unit dose, else a preservative will be needed for a multi-dose. It's not only applied for eye drops, I think the same for your parenteral injections. Okay. So then we have your buffer. So do we need a buffer? Okay, by looking at uh, again your PKB value. Okay, so as I say, I remember one of you asked me whether is there any unbuffered ophthalmic preparations. There are. Okay, so but in most of the case, even though that a PKB value may be suitable for the eyes, okay, but you still need to buffer it at a certain range. Okay, so the idea of buffer again is to make sure that the pH of the patient doesn't change um, when when you try to instill into your eyes. Okay, so the formulation can retain for a while the range is being accepted by the eye, so that it won't causing any irritations. Okay, so while it's how to adjust, how to resist the pH changes, so this is when the drug is able to absorb or permeate into your eyes. Okay, so antioxidant is not specifically mentioned or required in the but in the prescription itself. But I think one of the things that we can get about the information is um, the last point we mentioned, that it is easily degraded in the presence of air. Okay, so in this case, that it has a hint to you that the major compositions of the air that having interactions or in competitivity with your eye drops will be your oxygens. Okay, so where when we have incompatibilities with the airs, is means usually the interaction with the oxygen gas. Okay, so this is where the oxidation happens, where this oxidation also means the degradations of your compounds. Okay, so in this case, an antioxidant is needed. Okay, so viscosity agent is not specifically mentioned. Okay, so we can choose oak to add or not. Okay, so how about tonicity adjusting agent here? Okay, so I can see that there's a very low percentage of you choose to add in a tonicity adjusting agent. Okay, but we'll see how later on. Let's go to our next point. Okay. Okay, I think we have some quiz here. So can you join quickly? So we have 3 questions. Any more? So let's do a countdown. Hey. All right. So let's see what happens here. Okay. So I think majority, I think slightly more than 50% of you choose to have and to add or adjust the tonicity of the formulations. Okay. So let's go back to the questions again. Okay. So what happens? Let's go back to your questions. Okay, so let's go back to here. Okay, so we have some important informations to you. Okay, so I would like some volunteers. Okay, especially those that can switch on your mics. Okay, so can you tell me whether what makes you think, especially those that voted yes. So what makes you think that you need to add a tonicity adjusting agent? Okay, or you want to adjust the tonicity? Anyone? Feel free to talk. Okay. So I wish to have some interaction with you guys. So it's kind of boring if I just continue to talk on my own. Okay. So what makes you think? So you might need to have a calculator with you. Okay. So or a phone. It's just a simple calculations. Okay. Okay. I also wish if you some of you can help to share your calculations if you want. Okay. So don't be shy. Okay. So I'm waiting for volunteers to tell us why we need to add tonicity adjusting agent over here. Can someone please volunteer? Hello? Guys, are you there? So can we have some volunteers to show us the calculation quickly? So I believe that you guys will have mic if you're using phones or laptop. Okay. So just feel free. Don't be shy here. Okay. I'm not going to eat you. I'm not going to hurt you. Okay. So we want to see more interactions with you guys. Can someone please don't waste your time? Okay. So if you can't finish, I'm not going to continue the class. Okay. So it's just a simple calculations. Why we need a tonicity adjusting agent here. Okay. Can someone speed up? Can someone speak up? Oh. Oops. Sorry guys, I think I have mute the mic. Can you hear me now? Guys? Can you hear what I said just now? Can someone respond in the chat box? Do you hear what I said just now? Yes or no? Okay, so I can see some response here. So can we have some volunteers to share us the calculations? Or you can just open your mic and explain to us quickly how you reach to the decisions that you want to add an tonicity adjusting agents to the formulations. Okay, so what informations is or are important for you, and how you reach the conclusions that you want to add. Okay, can someone please? Okay, it's gonna waste your time, not my time. Okay, the 1 hour is yours. Can we have volunteers? Anyone just pick up, just share your opinions. Don't be afraid of getting wrongs or whatever. This is a learning process, guys. Okay, so if you don't learn from your mistake, how are you going to learn? Okay.
Hello, doctor.
Yes. Who are you on the
Uh,
line?
I'm Kashwin.
Okay. Thank you for responding. Yep.
Okay, I'm not very sure if my answer is right, but I just want to try, doctor.
Yeah, good.
Okay. So I think we need to add the adjusting agent. We need to adjust the tonicity because first we have to find the value amount of NaCl to be adjusted. So if we
Okay.
use the formula of NaCl equivalent method, which is E 1% of salicylate equals to 0.122 over 0.576. So we will
Yep.
get 0.219, which means 1% of salicylate is 0.219% of NaCl. So
Yep.
for 0.5% of salicylate will be 0.1095% of NaCl.
Yep. And then?
So amount to adjust will be 0.9 minus 0.1095, which will be 0.791%. So it is in the,
Yep.
uh,
Continue.
until there I know, but after that I'm not very sure how to continue.
Okay. So thanks for responding. I think basically, can you just keep on your mic on? Okay. So what makes you think that when you reach the equivalence of sodium chloride equivalence equal to 0.1 something percent? So what makes you think that you need to adjust in this case? How about if it's 0.3, 0.5? Okay, what makes you think that 0.1 you need to adjust?
Because initially I think I've doctor have explained that if the range is between 0.5 to 2, so we don't have to adjust, and if it's lesser than that, then we have to adjust.
Okay, very good. Okay, so thank you for responding. I think a very good students. Okay, so thanks for the response again. So I think what's your name again? Sorry.
Kashwin.
Kashmin. Okay, thanks Kashmin for responding. I think we need that kind of interactions. Okay, guys. So please participate in the class. I think from there whether you're right or wrong, so I can try to guide you so that you know what's right, what's wrong. Okay. So thank you again. And I think what your friend explained here is very excellent. Okay, so basically you have to remember that the range we are working on is 0.5 to 2% of sodium chloride. So within this percentage, our eyes can accept. Okay, but if usually dose is lower, okay, dose is higher is difficult because it's already more than that, so we can't do anything. So, but if less than that, so you need to adjust the tonicity. So when we adjust the tonicity, we will still go to the isotonicity. Okay, so we won't go like 0.5 or 0.6. Okay, just straight go to the 0.9%. So the remaining is going to be added with the sodium chloride. Okay, so in this case, it depends. Okay, so what can be used to adjust the tonicity, tonicity of the formulations? Okay, so the most straightforward plan, if there's nothing else ingredient added, okay, then you will have to factor in the tonicity adjusting agent itself, which is usually the salt like sodium chloride. Okay, so but what if there are more things present? Okay, so if let's say here we discuss that we need to have an antioxidant. Okay, so okay, we need to have three basic essential things for this formulation itself, which is your drug itself, your preservative, and your antioxidant apart from your vehicles. So don't forget that you have to remember whatever presence in the formulations will contribute to the tonicity. Okay, will contribute a little bit to the buffer. Okay, of the pH. Okay, so but usually the preservative itself, we will just ignore the calculations. Okay, because the amount used is usually very low. Okay, it's 0.0 something percent, and most of these preservative have a freezing point depression value which is very low. So when you try to work out the things, so the effect on the tonicity is not significant. Okay, so you can ignore the calculations for your whatever practical exercises, your test or exam. Okay, so but antioxidants or other or others ingredients, or it can be too active in one eye drop itself. Okay, so then you have to consider those things. Okay, antioxidant can be used at a very high percentage, as in like 0.1% or more. Okay, so and these antioxidant usually have a very high freezing point depression value. Okay, so when I'm talking about high or low for freezing point, low is like 0.00 or 0.09, 0.05. Okay, so but when it's high, it's like 0.1 and above. Okay, so I think one of the most common example for antioxidants is like sodium metabisulfite. Okay, so it has a freezing point depression value of 0.288, if I'm not 0.3386 or something, I can't remember. Okay, so so it's kind of high value with a percentage like 0.1%. So when you work out, so it contributes significantly to the tonicity adjusting agent. So in this case, you have to factor in the fact the tonicity contributed by your active and the tonicity contributed by your antioxidants. Okay, but the questions I asked just now, so asking you, sorry, oops. Okay. So I'm asking you if we assume that other ingredients are not contributing to the tonicity agent. Okay, just the drug itself. Okay. So in this case, we have to factor in. Okay, and then just consider whatever is contributed by the drugs. But when there is no such statement, then you have to base on your formula again. Okay, so in this case, your preservative, which is not significant, is okay, but your antioxidant has to be considered. Okay, and don't forget that if you need to add in a buffer, okay, so buffer also contributed to your tonicity. Okay, so it will work in a similar way like what we discussed for the antioxidant. Okay, so let's look at the next questions. So why do you think that, okay, I think we have discussed this one. Okay, so just jump off this. Okay, questions 2. Let's join. So the next question asking you to select a suitable preservative. If you're only given the choice below, okay. Okay. All right. So here, okay. So kind of disappointing. Okay. So majority for you will go to choose benzalkonium chloride, okay? So this is one of the most common type of preservative use, okay? So, but why in this case that it is not suitable, okay? Anyone can give your comments. So it's more than welcome, okay? If you can just talk like what your friends is now, Kashmir. Or if you have any ideas, opinions, okay, feel free to talk. Okay, so someone type in the chat box. Okay, so we have people saying that it's incompatible with salicylate. Okay, can cause corneal irritations. So what makes you choose the best preservative over here for your formulations? Okay. Okay, so if you're aware, we do have some incompatibilities of preservative, especially with a lot of this salt form. Okay, so so some certain salt like salicylate, nitrates. Okay, so they can be interact with your preservative and produce precipitations, so to cause ineffectiveness of the preservative. So over here, salicylate salt itself can interact with benzalkonium chloride. So in this case, it is not a suitable preservative. So you can just opt for other choices, which is more, it's not going to cause any problems. Okay. So yeah, so these are the things that you need to think of. Okay, so benzalkonium chloride has also some shortcomings, which I have discussed in the class. So if there is a special request from the questions, especially in the test, so you need to think from that kind of aspect. Okay. So let's go for the question 3. All right, so over here we ask you to choose a buffer. All right, so over here, okay, so we say that if we want the pH of the formulations to be 6.5, okay, so which one you should use, okay? So then that would depend on a lot of factors, okay? But I think at your level, okay, as long as you can choose the right pH, I will be more more than happy, okay? So so look at the range of the each of type of the buffer, okay? So if you look back at your manual, so we do have different combinations of, because buffer usually make up of salt and the acid or base. Okay, so in this case, they will have a certain range that they work the best. Okay, so and what we not discussing here is actually the buffering capacity. Okay, because I think it will be too much things for you to consider. Okay, but as long as you remember the basic needs, okay, at this point. Okay, so if we want to have a pH of formation to be 6.5, then of course we have to choose the buffer that can work out within the range. Okay, so the first 3 can work the best. Okay, so if you really do not have a choice, okay, so but boric buffer is the only one available in your store or in your pharmacy. Okay, so I mean you still have to add in a buffer. Okay, so since the Borel buffer has a range from 6.8 to 9.1, okay, so you still can choose the lowest one, which is 6.8, okay, because 6.5 is quite close to 6.8, okay, but if you have a better choice, okay, so you will have to choose those that are close to it. Okay, so let's say for certain phosphate vehicles, so it has a certain range. It's not exactly maybe 6.5. Maybe if the only available competition is 6.6, yeah, you still can choose. Okay, or 6.2. Okay, which is very very close to what you need. Okay. So any questions? All right. Okay, so let's see if you have any more. Okay, so right now, so we need a volunteer again. So please complete a label. So you can just use a Microsoft Words or whatever. Try to type a label. Okay, I give you some time, few minutes. Okay. So I have someone wish to annotate. Okay, done. I think I've given you the authority to annotate. If you want to type or write something, you can just type freely, I think. Yeah, you can even type. Okay, if you wish, I can give you the authority. You can just type on the screen right here. Else, if anyone volunteers again, I can assign you so that you can take over the presenter, then you can share your screen. I give you 2 minutes. Okay. So meanwhile, please volunteers to share the informations. Okay. Again, as I said, this is a training section for you. This is a discussion section for you. So if you want, we can utilize this time for you to know that what you should know and to know that what you go wrong. Okay. So I'll give you 2 minutes. Still have another questions to go. Or if you can't write out, can someone just read out a label? Okay, just pick up your label from the top to the bottoms that what informations you need. Okay, so labeling is one of the major main components in your it's not only in your test, okay, but also for as as part of your job as a pharmacist career. Okay, so anything that is indicated wrong on the labels, okay, so patient will just follow. Okay, so if you don't realize a mistake during your dispensing or during your compoundings, okay, so if you give the wrong informations or whatever written wrongly on the labels, so it's you can imagine the implications can be quite big. Okay, to the extent that patients could have lost their life. Okay, so who is Ladan? I give you the annotations authority. You can annotate on the screen. Else, I would need a volunteers. Okay. So you have a lab manner. Okay, if you have a lab manner with you, okay, so you can refer your lab manner again. I've given you that what information should be needed as a standard labeling for, okay, so it can be very different from what you have learned for 122, which is for non-sterile preparations. Okay, sterile preparation we have more strict labeling requirements. Okay, so and different type of steroid preparations, injections, even injection themselves can have different types. So each type will have a different labeling requirements. Okay. So can someone? So is Ladan on the line? Hello. So I make you unmute. So Ladan, hello. Can you speak? Hello. Hello, Ladan. Hello, can you hear me? Oops. Yes. So I feel like I'm DJ in the radio. Here calling for consumer. Hello, you win the prize. So guys, please participate actively in the class. Okay, just don't let me talk. Okay. So we have a very good example from your friends, Cashwin. So can we have more volunteers in this case? Yeah, you can speed up. You can share your screens. I can make you. Yeah. Ladan, can you speed up instead of writing? Okay, you have a weak connection. Yeah, what we want is a complete label. Okay, a complete label. Anyone else can replace? Hello guys, I have 123 mice. Okay, can you? Okay. So we have one volunteer here. Neo, can you speak? Hello, Neo. This is DJ Go here. Can you hear me? Hello, Neo. Can you speak?
Hello, doctor.
Yes, good. So can you just quickly go through your labels from the top to the bottom? What are the requirements?
First is the
Can you
product
be a
name.
little bit louder? Can you close to your mic a little bit more?
Because my mic is with the cam.
Okay. Okay.
Maybe
It's yeah, okay. Try your best, yes.
the first thing is the product name and how to the method to apply and apply for the duration time, apply for how long.
Okay, can you just speed up but not just mention what you need? Just read out the exactly.
Okay. Artex salicylate 0.5% W/V. I drops apply drop by drop 2 times a day for 2 months.
Okay.
For ophthalmic use only, please
Yep.
discard after few months. I don't know exactly the month, so I just
Okay.
put a
All right.
blank here.
Yep.
And the date.
Yep.
The
So what
patient
date you
name,
need?
the discard date,
Okay. Yep. Okay.
and the patient name, dispensing date,
Yep.
and the warning, like
Okay.
hit of children, hit on dry place, etc.
Okay. Okay. Keep
The
on.
label should be red.
Yep. Okay. So keep on the line. Keep on the line. Okay. So okay. Thanks again, Neo, for speaking up. Okay. So okay. So let's go from the top again from what you have talking about. So don't if you're referring back to the manual. Okay. So for eye drops itself, I think the volume say that is that critical, but I think sometimes it's good if you can mention the volume that you prepare. Okay, so how many mils? Then you can follow by your names. Okay, so the names here Okay, whatever your friends mentioned just now is correct. Okay, because in this case that this drug has been given to you the name. Okay, so let's say if you don't have any ideas, so few things you have to remember is what is the active, what is the concentration of the active, and also what is the dosage form. Okay, you need to mention is it eye drops or not. Okay, you can't just stop azic salicylate or azic salicylate 0.5%. Okay, weight per volume. Okay, can't stop there because else we won't know that is it this label indicated for this eye drop. Okay, so you need to mention eye drops. Okay, so and then come for the directions. Okay, you mentioned 5 drops 2 times a day. Okay, for 2 months. Okay, so it has to be very careful here because so it depends on the situations. So over here that if you don't mention specifically left or right eyes, okay, so you have to put the directions to both eyes, okay, or if you're not sure, you have to ask the patients, okay, so to the eyes, okay, as directed by the doctor, okay, if there is a such label, so it will indicate it in your by the physicians in your prescriptions, okay. So other things what your friends has mentioned is quite right. I think so. Another thing is the auxiliary labels. So auxiliary labels is also very important. Okay, so for external use only. Okay, to protect from sunlight. Okay, or protect from light. Okay, so some of these it would then depends on the need. Okay, you can check information based on BBC itself. Okay, so or can be based on the individual drugs. Okay. And don't forget that we have 3 dates here on our labels, okay? So which I think in normal commercial product, you will usually see only 1 date, which is the expiry date, okay? But for your practicals, there will be 3 dates you need to mention, okay? So one is the expiry date, okay? If the exact expiry date cannot be known, so you must have indications of how or when it should be discussed, maybe after first opening or whatever, depends on the sterilization method. Okay, then followed by your sterilization date, and the last one is your dispensing date. Okay. So don't forget the informations about patients, the patient names, which always left out. Okay. Okay, so we are done here for this one. Thank you again, Neo. So let's go to the next one. I think we are a bit short of time. Okay. So guys, please be more active in participating in the class so that I don't have to waste the time to wait for you. Okay. So now switch the Mentimeter to another code 237165O. Okay. So we are now giving you a second example. Okay. So drug FAR IV 350 milligrams DS. Okay. So I also copy the information to the chat box so you can follow up. Okay, so this drug is easily degraded with heat. Okay, and freezing point depression value is 0.091. So please jot down the value. Okay, so aqueous solubility is 100 milligram per ml. Okay. Okay, so hope you have jot down the informations now. So as everyone in the Mentimeter, the new Mentimeter now. Okay, so I'm going to continue, else we're going to finish this. Okay, late. Okay, so the first question asking you, how do you want to formulate it? Okay, you want to form an ampoule, a multi-dose injection vial, IV infusions. Okay. So asking you how to formulate it, but not how to administer it. Okay. So what are the informations present are important for you to know that you should go for ampoules, multi-dose vials, or IV infusions. Okay. So it can be also pre-filled syringes, okay? But I try to limit the choice to what we have in the practical class, okay? So we can see right now that most of you chose multi-dose injections, then ampoule, then IV infusion, okay? Okay, so what makes you would like to formulate, okay? Okay, so I think we have an answer already here that most of you voice out to have this to be formulated as a multi-dose injections. Okay, let's see. Okay, so from these three formulations, okay, the most suitable one would be either ampoule or multi-dose injections. Okay, so IV infusions wouldn't be suitable for drugs. Okay, so why in this case? Because the amount of the dose given is actually very low. Okay, so IV infusions usually is indicated for salt. Okay, salt formulations. Okay, you can find ready infusion bottles containing some of the drugs. Okay, but it is very rare. I have to say. Okay, so but when these drugs is given, they may be given through infusions method. Okay, but when you formulate it, which one is the best? Okay. So let's look at the next questions. Okay. Okay. So how do you want to determine a suitable dosage form? Okay. So few things you need. Okay. So first thing, the properties of the drugs, including the stability. Okay. So in these questions, specifically, I say that this drug is easily degraded with heat. Okay. So then this is actually related to the stability issue. Okay. And not only stability, I mean the physical chemical properties of the drug is important. So this including the solubility, which we will mention next. Okay. So but does heat unstable, would it affect any of the choice of your dosage form? Okay. Practically not. Okay. Because what we usually will face heat during the processing or manufacturing or your sterile preparations is usually your sterilization process. Okay, so your sterilization process, even though with heat sensitive, you can choose or opt for the non-heat type of sterilization process. Okay, so commonly used dose. Okay, so okay, over here you're given 350 milligram. Okay, so in general, this is a rather low dose. So when a dose is high, we are talking about like in gram. Okay, but even though in grams, for some formulation, it is still present in the form of a multi-dose. Wow. Okay, so this is because the convenience. Okay, so one of the example is like ceftriaxone, which is one of your antibiotics. Okay, so it's usually having a dose of I mean inside a multi-dose vial, so it's usually present as a multi-dose vial. You can have I think 500 milligram, 1 gram, and 2 grams. Okay, so but usually these drugs, these antibiotics are given through infusions. Okay, so because of the bulk issue, okay, of the storage issue, so we won't formulate this one into IV infusion, even though it is going to be diluted into your IV bottles to be given through infusions. But because of the storage issue, so instead of storing a small bottle and a big giant bottles of infusions, so we are going to think of which one should be the most convenient one. Okay. So in this case, we have to choose the multi-dose vial type, or it can be also in ampoule. Okay. So the next point, which is related to the properties, is your solubility issue. Okay. So let's say you have a drug that is hardly soluble. Okay. So it's still aqueous soluble, but it's needed more volume. Okay. The solubility is slightly poor. Okay. In this case, means that you need more proportions of water in order to dissolve the drugs. So in this case, you might have to take off to eliminate the choice of ampoule. Okay, so else you have to formulate an ampule which is like 20 mil, okay, which is not reasonable, okay. And the volume of the formulation needed, okay, so this will depend on the situations, okay, which in this case is also quite related to what we talked about just now, the solubility, okay. So route of administrations, okay, so and its method. So as I said just now, by giving you the example, okay, so we can given two IV infusions, but we don't necessarily have to formulate it as an IV infusion bottle, okay. This would then depends on the need, okay, and we have to think of the storage, okay, how much space you need, okay, and then when we think of economically, it's not economically friendly because it's gonna charge you a lot for packaging, it's gonna charge you a lot for transporting, okay. All right, so by giving you some ideas for what we have just now, so let's go back a little bit. Okay, from the things here, so multi-dose vial is still the best choice, okay. So even though you might think of you can formulate into an ampule, okay. So okay, why we think multi-dose vial can be more suitable, because first thing that, and of course it's given multiple times, okay. So if you think of you from the solubility aspect, okay, 100 milligram per mil. So if you're going to stick with this concentrations for your formulation, so you're going to have a 3.5 mil, okay. So given 3 times a day, so I think practically if you want to use an ampule, it's still okay, because if you have a 5 mil ampule, okay, it still work out, but the only things you have to think of, you're going to waste another 1.5 mil, okay. However, what if you think that I'm going to consume over here 3.5 mil, if you have an injection vial which is 20 mil, so I can use at least 5 to 6 times, okay. So in terms of cost wise, I think multi-dose injections can be more suitable, okay. All right, so let's go. Okay, so let's go back to this spider web again, okay. So this will be very helpful and handy for this spider web when you come into your practical questions, okay. So when you save a questions, if nothing is given, what do you think from this field aspect is important, okay. So based on our situation right now, okay, so do we need a vehicles, a preservative, a buffer, and then an antioxidants, viscosity, and tonicity adjusting agents? Do we need them? Okay. I think we're gonna take another 10 minutes, I think, yeah. Okay, do we have more? So by looking at the situation right now, I think we have more or less the same trend as what you have chosen for your ophthalmic preparations, okay. So in this case, it's not surprise because they are both multi-dose type of steroid preparations, okay. So which means your vehicles and preservative are important, okay. So there's only one case where your vehicles, I wouldn't say it's not important, but I have to say it's not necessary, okay, if given that your drug, okay, your drug is not stable in the presence of water, okay. So it means that in the presence of water, it cannot stay long, okay. It may undergo hydrolysis as a form of degradation. So in that case, that you might have to think of just to prepare your drugs in the form of powder, okay. When you need to use them, you just have to reconstitute with a certain amount of water to achieve the exact concentration that you plan, okay. So that is possible. Or there is another trend which is quite similar to this, is the freeze dry form, okay. So meaning that you still need to prepare the drugs in the form of liquid, but you're going to freeze and dry them, okay. So remains the drug itself still, okay. So preservative is definitely a need for multi-dose vial. So if you're going to formulate an ampoule, again, there is not need for a preservative. Okay, or in one of the case, if the injection vial. Okay, so don't confuse when you look at the injection vial. Okay, so as I said, the injection vial can be used for single dose, can be used for multiple dose. Okay, so when we mention multiple dose injection, it doesn't referring to the vial itself. Okay, so but the vial is just injection vial. Okay, so buffer is not mentioned specifically, so you can choose not to add. Same for antioxidants. Okay, viscosity, no need. Okay, at all. Okay, yeah. So the most confusing you here is the tonicity adjusting agent. Okay, so I think I'm going to ask the questions next. Yeah, I think we have two questions. I think should be quite related to tonicity. Okay, so let's go to the questions. Oh no, okay, we'll come back that later. Never mind. Okay. So based on what we have discussed just now, choose a suitable sterilization method. Okay, time's up. Let's see. All right. Okay. Haha. So you gotcha. Okay. So yeah, I mean most of these methods are available in the lab, except for the last one, which is radiations. Okay. So can someone speak up or can someone put in the chat box what makes you think that you want to choose aseptic filtration for those who answer it, the 26 of you? Anyone? Can you share why you think that aseptic filtration is your method of sterilization? Hello. So don't get your DJ Go here boring. Yes, no heat, not using heat because it's easily degraded when heat. Aseptic filtration does not involve heat. Yep. Okay. So majority of you hit the right question. Hit the right point. Okay. So don't forget that in the very beginning, I especially mentioned that this jar is sensitive to heat. Okay, it will degrade with heat. Okay, so you have to use a non-heat method. Okay, so out of here, okay, aseptic filtration and radiations are the two that doesn't involve heat. Okay. Okay, so one of the more confusing part is number one, okay, which I purposely put it first. Okay, if you do not read the questions or the answer carefully, then you fell into the trap. Okay, so I would like to mention again here, aseptic technique is nothing to do with aseptic filtrations. Okay, so it's two different things. Okay, aseptic technique is just the technique itself is aseptic. Okay, but aseptic filtration is the filtration process that being done in an aseptic conditions or in an aseptic room. Okay, so you need to be very clear that which method you are specially mentioned. If you just use this bay aseptic technique, how? Okay, how the process of sterilization happens? It's just aseptic, but nothing. Okay, how are you going to make sure that the microorganisms are being killed or being removed? Okay, it's the filtration process. Okay, but this filtration process is being conducted in an aseptic environment. Okay, which is free from particles and also microorganisms. Okay, so don't get confused with the terms. So if you answer in the questions later on, you mention aseptic technique, no marks. Okay. So let's see the next questions. Yeah, radiations does not involve heat, but I think so it's just theoretically we mentioned here, but in your practical class, okay, so we won't use radiations. Okay, it's too dangerous here. Okay, let's go to the next questions. Aha, okay. They are given you too short time here. Time's up. All right. Let's see. Again, we need to adjust the tonicity. Okay. So if you don't have time, give you 2 minutes right now. Okay. Go and calculate again. And what makes you think you need to adjust the tonicity? Okay. Can someone also volunteers to speed up? Okay. So why you need to add or adjust the tonicity? Okay, I give you 2 minutes. Okay, so can we have volunteers? Anyone? Anyone, please? So do we need to adjust the tonicity? Yes, but why? Someone, please.
Hello, doctor.
Yes, who is on the line?
My name is Husna.
Yep, Husna. Thanks for responding. Yep.
I think we can use the NaCl equivalent method to find the
Yeah.
E1%.
Mm-hmm.
So we get 0.16%.
Mm-hmm.
So it is less than 0.9%. So it is hypotonic.
Okay.
So we need to adjust the tonicity.
Okay.
But I'm not sure if is that correct or not. Okay.
Okay. So thanks again for your response. Okay, so your friends mentioned that this drug is hypotonic and you need to be adjusted. Okay. So okay, even though I say you remember are there hypertonic formulation in the market? I did say yes, but I think you have to remember that even though the hypotonic is available, but I think it's only limited to a certain type of formulations. Okay, but in general, hypotonic solutions we need to adjust the tonicity. Okay, so but if the drug or if the formulation itself is hypertonic, okay, I think generally it's still okay. Okay, you don't need to specifically adjust the tonicity. Okay, if it's in isotonic form or in hypertonic form. Okay, but if the thing is in hypertonic form, which this only limits to two situations. Okay, which is your MPU and your multi-dose vial. Okay, unless specifically saying that isotonicity is not a concern in the formulations. Okay, else if hypertonic solution presence in these two formulations, you have to formulate it into isotonic formulations. Okay. However, for IV infusions, usually we don't need to specifically adjust the tonicity. Okay, unless requested by the questions. Okay. So yeah, I mean one of our friend mentioned here we use the same method as we discussed just now for ophthalmic formulations. But again, you can also think of to just use a simple freezing point depression value method, okay, which over here I don't limit you the choice of method you can use to calculate, okay, but in exam, okay, I will specifically, or in the test, I will specifically mention what kind of method you should use, okay. So you have to follow exactly the method strictly. So if you start to mix up other kind of method into the calculations, you're not going to receive any marks onwards, okay. Okay, so and over here, what your friend saying just now is right, is correct. Thanks again, Husna, right? Okay, so yeah, if another way you can think of is using the freezing point depression value to cross-check quickly. Okay, so this is the most simplest form of calculations out of the 4 methods you have. So use it quickly to cross-check the answer first. Okay, so you remember we say that it has to be reaching 0.52 negative 0.52 degrees Celsius for which is same as your freezing point depression value point as freezing point of your blood plasma. Okay, so in this case, so when you work out the formulations given, okay, if you want to calculate the I think it's the B, right? If I'm not sure, if I'm not mistaken, the B value. So it's 0.52 minus whatever is present, okay? So if you get a value which is positive, okay, so means that you need to add in something, okay? So it means that the formulation is still in the hypotonic form, okay? So but what if the value that you're going to minus is bigger than 0.52? So ultimately you get a negative result, okay? So when you get a negative result using a freezing point depression value, meaning that you are owing a system more. So meaning in this case, your formulations is in hypertonic form. So means that you don't need to adjust specifically for this kind of formulations, okay? So only adjust if it's less than the system, which is, it means that it's in hypotonic situations, okay? So I hope that is clear for you. Okay, so I just summarize a little bit. So when you adjust isotonic, you don't need to adjust. So more than needed, hypertonic, you don't need to adjust, okay? You only need to adjust if less than needed, okay, which is hypertonic, or in another case, which I don't mention here, is when it's required by the questions, okay? So, all right, I think, thank you again for your attentions. So I think we see some improvement here. So I get to see a few of you participate. So I hope you get more that kind of interactions. Okay, volunteer yourself. I'm not going to see you, so I'm going to miss your voice as well. So just not that you miss my voice. Okay, so we need some human touch, even though we can't touch physically. So, all right. So again, if we have 1 or 2 minutes to go through, if anyone have any questions you want to ask right now, can put in the chat box, but I preferably if someone can speak up. Okay, any more? If no, I'm gonna end the sections, and we'll see you this Thursday for the Suture and Literature class, which my last lecture with you guys. Okay, so make sure you watch the video lecture before coming to the class. Okay, so again, want to highlight that you have any questions, please put the e-learns. We can all learn together. I'll try to respond to you. Okay. So thank you, and then take care. Goodbye.
Thank you, Doctor.
All right.